Okay, so in this problem we're given a ratio for sine, and sine, I hope you know, is the y value or the opposite side over the radius or the hypotenuse. Sorry, that's supposed to be a y. I said y but wrote x. And we're told that we have a quadrant 2. So our triangle that we draw is going to be over here to the left of your origin. So that is the angle that we're talking about that has a sine of 4/9. So the first thing we have to do in order to figure out these double angles, since they all use cosine, is find the x value so we can have the cosine ratio. So we use our Pythagorean theorem. 9 squared equals 4 squared plus x squared. 81 minus 16. So x is the square root of 65. And because it's in the second quadrant, it is a negative radical. Okay, the Pythagorean theorem won't tell you that, but your knowledge of quadrants and algebra will. So we have an x value of negative root 65, and now we're able to use these formulas for sine of 2 theta. So the sine of 2 theta has the formula square root. Since sine is positive in the second quadrant, we'll leave it like that. 1 minus the cosine. Nope, that's the half angle formula. Never mind. I know I was confusing y'all. Sorry. The double angle formula says 2 sines times the cosine. So the sine is 4/9. The cosine is negative root 65/9. And now we simply multiply a bunch of fractions. 2 times 4 times this is negative 8 roots of 65. And 9 times 9 is 81. So we get this lovely mixed radical with a fraction in it that happens to be negative.